Alright, so for this video, we're going to be looking at variables and debugging. So, first things first, what is a variable? So, basically, really the formal definition is a named storage location, or a named location in memory. But that's kind of, I like to explain it like this. When we create a variable, we're essentially asking the computer to store something in memory, right? So, we also name that storage location so that we can return to it in the future. So, for example, I might come up with a variable like int number is 5, right? Or better yet, I can say int number is 5. So, what is the syntax of variable creation? So, this right here, this bit, number, this is what's called variable declaration. Now, these two slashes right here just basically mean that this line or anything past these two slashes is a comment, and comments are basically just ignored by the program. But either way, so this is a variable declaration. Basically, what I'm telling the computer is I'm saying, hey, look for a place in memory where you can store this value number, where you can set aside some memory for me, so that I can have an integer stored somewhere, and I'm going to call this integer storage location number, right? So why do we have int for Java? Or no, sorry, why do we have an int before variable name? The int is just something that specifies the data type of the variable, and a data type is just basically you telling the computer kind of what you want to what do you want the data to be treated like, right? So if you want the data to be treated like an integer, you can use the int data type. If I wanted it to be treated more like a really small number, I might use byte. Just like that. So byte has a much lower range of numbers than int does. So int can store values up to like 4 billion or something like that because it's a 4-bit kind of variable. Um, but byte can only store up to like 256, or if it's unsigned, it'll be like negative 128 to, or negative 127 to 128, something like that. But I digress. And of course, we also have other data types like string. String is basically just uh, string is basically just a data type that stores text, and it's kind of simple, really. But yeah, so all we're doing when we type int or byte or string or double before variable names, we're just telling computer, hey, this variable is going to be represented or used in the way that a variable of this type would be used. So I would say, hey, computer, I want to get an integer. I'm going to, or I want to get a variable named number that's going to be treated, right, number that's going to be treated like an integer, or I'm going to get a byte number that's going to be treated like a byte. I'm going to get a string s that's going to be treated string. That's all basically we're saying. And then we're saying, all right, and reserve the necessary memory for all the possible values of this, or not all the possible, but like for the possible values that we might use. Basically, just reserve the memory that we might use for this variable. So that's the variable declaration. Before I go on, this right here is what's called variable initialization. Variable initialization is basically just saying, I'm going to now initialize the variable as some value. Because by default, variables are set to, I think, either like when a program is like an application is shipped and you haven't actually initialized variables, it's set to like some random value. But when you're like debugging code, it'll be set to, I think, the maximum value possible. So, or like, or some special value that the compiler has set or whatever. But not important, right? Basically, variable initialization just basically uh, stops term stops the program from being unpredictable. so to speak. You can also see here, I've combined both a declaration of a variable and initialization in one line. Right? So here I've not only said, hey, computer, I want to create a variable named s of data type string. I also said, and I'm going to initialize it or assign it this. Now, you might also see, when it comes to strings, you might also see something like this. String, say, name, new string, and then something like gondola or whatever. And this is also correct. It's just very different, and if you're new to programming, you're not going to really understand exactly what's going on right now. But essentially, just think of this sort of, just kind of similar to saying this. Wow, that's not going to like this because I redefined it. Either way, these two lines are kind of equivalent, but later on, when you go into like, when we get into references and other stuff like that, really just what is actually like memory locations and addresses and whatnot. You see, these aren't really equivalent, but they're very similar. Because if you output, let's just name this name one. If you output name and name one, you're gonna have the same exact output. So let me show you. So we output name, right? Putting one. Let's go ahead. You see, it outputs the same thing. They both look the same. But anyways, I mean, so for right now, these two are kind of the same, but not really. I digress. So now you'll notice that after declaring a variable, initializing a variable, or declaring and initializing a variable in one line, I always put a semicolon after that. That's because it's a statement. You can think of a statement in Java as like something that does one thing, right? Or does like does one action, right? So this is why later on when we learn about control flow statements, like an if statement, like this, we don't put a semicolon here because this isn't really doing one thing per se. It's not really, um, it's not the same as saying, you know, get me some memory for this, or get me some memory for this integer called number, or change this number to 5. It's asking a question rather than making a statement. So it's saying, you know, it's basically asking, is number equal to 5? If it is, then do the stuff in here. If it's not, then go out. Skip this whole entire block of code. That's for another. So let's talk about now the concatenation operator. Actually, better yet, before I do that, let's talk about this. So you can manipulate variables in Java easily. So like, let's say I want to make number equal to 5 plus 1. The number will be 6. So if we output number before this line, we output number like right here on this line, right below line 10 on line 11, we'll get output 5. We output it after number 5 plus 6, 6 as our output. Now, we can also just say number equals number plus 1. Now, what does this do? It basically says that's what you think. So if number is 6 right here, then we're basically saying that number is equal to our value number is, which is 6, plus 1, which means that this will be 7. So that if we output that, get a 7, and you can do all sorts of, you know, you can do multiplication, division, addition, subtraction, and all that stuff. Variables, very simple stuff. Also, the shorthand notation for saying number equals number plus 1 be something like number just plus equals 1. And this can be kind of hard to read at first because it's like, what does this even mean? But it's just the shorthand for this. It's the same thing. Just a little more concise. But also, if we just want to increment a variable by just 1, we could just do this. It's called an increment operator. It's very different from this because, like, for example, if I want to do number equals number plus 2, I could do it these two ways, right? But number plus plus only increments it by 1 and only 1. Similarly, if we want to subtract 1 from it, instead of doing plus plus, we can do minus minus. We get up with whatever this is. So this would be 7 plus 2, that's 9. So 9 minus 1 is 8. So we'd end up with 8. You can also do something that the same thing with like divides equals, so number equals number divided by 2. So that that would end up with 9 divided by 2, which is like it would truncate to 4, but so this is all fine and dandy. But there's another thing that needs to be said, and that's that the string concatenation operator. We can use what's called a concatenation operator with strings and any other variables when we're talking about printing something, right? So if I want to print something like the variable name, then I want to also print number variable like byte number. Let's just set byte number to something like 7. So I can do this by doing name plus, and let's do number. So see that prints out gondola, and then we expect no. Let's see. So is that right? Hold on. Let's see. 6. Now that 8. This would be 10. Then that would be 9. Okay, yeah. All right. But the issue is that these two things are right next to each other. So what can we do? We can add in. Basically, it's interesting because we're able to just basically concatenate, which means combine, kind of, strings, and then this number is implicitly kind of passed in. Substitute for that. I think you get the idea. Kind of hard to explain. So simple, like yeah. And we can do the same thing with another thing like byte number. And these things don't have to be spaces; they can totally be just like commas or whatever. Run it. See that the result is what we'd expect. All right. That's variables. The operation. Now, let's talk about debugging. So let's say I have some statements like, and then I go on to say, so number equals 5, and do an if statement. What this means yet? I put a semicolon after it. Say system dot print I. So if we try to, this is what these are all like called syntax errors. So up until now, I've shown you code that doesn't really have many errors, and if there is, I've quickly fixed them. But there are 2 types of errors that programmers are like bound to run into or encounter the most. The first type is syntax errors. Syntax errors make it so that your program doesn't run. It generally means there's some kind of rule of the syntax that you've broken. And the syntax of a programming language is really just like a set of rules that govern how the computer will understand what you've written. So if we end up messing up those rules, if we end up screwing them up, the computer will look at it and say, "I can't read this. I can't interpret this. What's going on?" And it'll just spit it back out at us, and it won't even run it basically. So if we try to run this, right? Do this. See that it doesn't run, but instead it VS Code brings us over here to the problems tab on the IDE. And this is actually like the best way you can actually detect syntax errors. because it'll literally just tell you, hey, here are syntax errors right down here. Syntax error. Insert semicolon to complete statement. Whereas this, it says right here, this is line 10, and I think that's column 18. So this right here, 10, comma 18, that is on line 10. Or we can just click it too, right there. 18, and it's just add a semicolon. It says. Then we still have one left, so what's the problem here? And it says, let's see, system up. Yeah, this seems all backed up. So what do we do? It's like, got to close the parentheses over here. We're inside the code, then you go outside the code. Okay. Okay, so now that that's done, let's see if we can't run it. See how output's 5. Now, why it did that when there's a semicolon here, I don't know. That's actually because it shouldn't be able to do that. But yes, I guess maybe VS Code is just kind of lenient or whatever JDK or JDE version I'm see. I don't know, but you shouldn't put a semicolon after statement. Yeah, double time. Yeah, so the best way to do run into syntax errors or any other kind of things that you should probably look at is through the problems tab on Visual Studio. We see this like the value of the local variable byte numbers. What does that mean? That means that this is basically just it's not used in the program. It didn't ever do anything. Like at least here we're looking at we're assigning it a value, seeing if it's equal to something. Which is something that just don't worry about if statements for but either. So about that. Let's talk about the second type of errors that programmers will do. So the first type of error, or I'm sorry, that was the first type of error programming. But the thing is that after a while, you're gonna get like really used to writing in the correct syntax of a language. And honestly, on the surface, almost every language, the only difference between almost every language is just the syntax. Almost every language there is has the constructs of like variables, if statements, else statements, while loops, all that stuff. We haven't gotten into those yet, but if you know anything about them, you can kind of, or if you've taken a programming class before, you can kind of understand. Oh, hey, I learned this in Python, or oh, hey, I learned this in C++ or something. Hey, wait, this is kind of really similar to what we did. That's because they're the same constructs, same building blocks, just a different way of writing them. And the reasons why you might want to use different programming languages vary, but I digress. So, logic errors are the second kind of error that we're going to run into when it comes to programming. Logic errors have to do with logic errors. Your program will run, and it will execute. The computer will take the code you've written and say, "Okay, I'm going to run this." Not made any syntax errors. The issue is that you'll get the wrong result. While your program will run, something will go awry in what's in the program. So there's only one good example I can give of this. So let's say we have this byte right here, right? And I say, okay, this byte number, I want to increment it by 1, right? That is equivalent to saying byte plus 1, or byte equals byte plus 1. So basically we're going to end up with 128. So I say byte plus plus. Oh yeah, hello. Byte number plus plus. Right? So then I'm like, oh, so then I say, okay, and I want to output this byte number, right? So, looking at this, we should think that that the number will be incremented to 128. Byte number should be 28 now. So and so the output that we're going to see should be 128. So let's run it. This is it's a negative 128. What happened? That's so weird. Huh. But you see, our program ran. There were no syntax errors. But something went wrong with what we did. We made a mistake. You see, with syntax errors, the computer doesn't understand what we're trying to tell it to do. Right? So we made we mess up on the syntax or something. We don't syntax error with syntax errors. It's like, dang it, why doesn't the computer understand me? When it's a logic error, it's more like we don't understand what's really happening with the computer or something like that. I don't know. But either way, so what's the problem here? Well, a byte data type can only store values if it has a sign from negative 128 to 127. So then what happens when we try to add 1 to 127? What happens is called a overflow, or perhaps an underflow, but basically what happens is that this value, it wraps around. Once you add 1, it wraps around to negative 8. So this is a logic error. So what can I do to fix this, really, if I think about it? Well, the issue is that the byte number, it can't store as much, the size of the number I need. So what I could do is I could just say int. Just rename this to int. Make this an integer data type variable, and then rerun it. As we'll see, we have 128. No problem. Right? So, I guess that's all for this lesson. Hopefully you found this helpful, useful, anything like that. Really, I just wanted to show how you can use variables and how you can use VS Code to detect syntax errors, but also to show you to be kind of wary of the fact that logic errors are harder to catch, and you won't encounter them as much at first when you're doing simpler programs, but as the programs get more and more advanced, inevitably you're going to run into some, so you're going to probably need to do some more advanced debugging, but that will be